Welcome to the high-stakes table, everyone. You are sitting down for your Cambridge mathematics examinations, maybe the 0580 paper, or perhaps you're tackling the 0606, 4024, or even the 4037. Whichever paper is in front of you, you need to treat it like a casino table. Every single mark is a chip. The examiner is the dealer, and right now you need to know exactly when to hold, when to fold, and when to go completely all in. I am your strategist, and today we are going to master one of the most critical, real-world modules in the entire syllabus, the life cycle of money and financial mathematics. Now, over the years, I've seen exactly how students lose their chips. Take Alex, for example. Alex overloads his paper with raw mathematical facts, but provides zero structured analysis. Or look at Sam. Sam rushes the paper, panics under the ticking clock, and completely misses the command word requirements. We are going to look at their flawed answers, correct them with the red pen of an examiner, and build an unstoppable mathematical toolkit. We'll be moving step by step from earning and exchanging cash all the way to the explosive mechanics of compound interest. Let's play the examiner's game, and let's win big. Here is our ultimate game plan for today, to beat the house. Section 1, Exchanging Global Currencies. This is where we pick up our easy, early chips. Section 2, Earnings and Deductions, where we learn how to dodge the examiner's trickiest traps. Section 3, Calculating Profit and Loss, where we hold our ground and secure those vital method marks. Section 4, Simple Interest Basics. And finally, Section 5, the Compound Interest Formula. This is the heavyweight champion of the syllabus, where we go all in for those massive, grade-defining extended marks. Grab your calculator, clear your mind, and let's jump right into the first phase. Section 1. Exchanging global currencies. Time to decode our first set of command words and start stacking those marks. All right, here is our first challenge, and it's a classic data scan. On your exam paper, this is going to look like a complex data table. This specific data, drawn straight from our financial mathematics source, shows us the exchange rate for exactly €1. The baseline is established. For every single euro you hold, you could trade it for 1.50 Australian dollars, 75 Indian rupees, 1.15 US dollars, or 130 Japanese yen. Now, a student like Alex will just stare at these numbers, maybe underline them all, and overload his brain. But as a master strategist, you need to extract the core trend immediately. It's the mathematical foundation of international trade. The examiner is literally giving you the conversion key. The question is, how do we actually structure our answer to use this in practice without dropping a single method mark? Let's look at this brilliantly simple step-by-step breakdown. This right here is exactly how top-tier students format their working out. Suppose the command word says calculate how many Australian dollars you can buy with 400 euros. Step 1, you clearly identify your baseline rate on the page, which we know is 1.50. You write that down. That's your evidence. Step 2 is the execution. You simply multiply your target amount, 400 euros, by that rate of 1.50. You show that exact multiplication line. The result? 600 Australian dollars. It's a straightforward multiplication, but showing those 3 distinct steps is what guarantees you 100% of the marks. Before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, locking in those foreign exchange marks is crucial because they form the baseline of your grade. Moving swiftly along to Section 2, Earnings and Deductions. This is where the examiner starts setting invisible traps. The absolute most critical concept to grasp in this section is the strict definition of net pay. In the real working world and all over your Cambridge 0580 papers, you'll hear the term gross pay. That's the top line number, the massive total amount you technically earned before anyone touched it. But as this definition makes crystal clear, net pay is the only thing that really matters. It's the reality of what actually hits your bank account after all the deductions, like tax, national insurance, and pension contributions are aggressively stripped away. Gross pay minus deductions equals net pay. I cannot tell you how many times I've seen Sam rush a question, calculate the gross pay perfectly, completely ignore the deductions command word in the second half of the paragraph, and lose 3 marks instantly. Don't be like Sam. Read the whole narrative. Now, I absolutely love this piecework problem from our source material because it actively challenges us to think completely outside the traditional hourly wage box. This is a classic curveball. Maria doesn't get paid by the hour, she gets paid by the unit. She earns €5 for every batch of 12 plates. If she churns out 1,260 plates in a week, how do we find her gross pay? Let's apply our strategic structure. First, we need to divide her total output 1260. By her batch size of 12, that means she produced exactly 105 batches. Then we multiply those 105 batches by her €5 rate, giving us €525. Notice how we didn't panic at the weird numbers? It perfectly illustrates how identifying your base unit first is the absolute key to solving complex wage mathematics. You break the problem down to its studs and then build it back up. Excellent! Let's roll right into Section 3, Calculating Profit and Loss. We are shifting gears from personal earnings to harsh business realities. We all know the terrible feeling of buying something incredibly shiny and new, only for it to lose its shine and a huge chunk of its monetary value the minute you take it home. This brings us to the formal mathematical definition of depreciation. It occurs when an asset simply becomes worth less over a period of time. It is the ultimate, silent enemy of your original cost price. And Cambridge examiners absolutely love testing your understanding of this concept because it requires you to track value backwards. Let's see how this destructive force actually looks when we put real exam-style numbers to it. Here is a perfect before and after transformation of how to answer a depreciation question. Let's walk through this real-world example of a woman selling her car. Step 1. You clearly state the cost price. She buys the car for $7,500. Step 2. 2 years later, her selling price is $4,500. Step 3. A simple subtraction gives us a raw monetary loss of $3,000. Now, here is where Sam usually stops, thinking he's done. But the command word was calculate the percentage loss. So step 4 is where the top tier marks live. To find the percentage loss, we take that actual loss of $3,000, divide it by the original cost price of $7,500, always the original, never the new price, and multiply by 100. Boom. That is a massive 40% depreciation loss. Writing it out like this, step by step, turns red pen marks into green check marks every single time. And that brings us to Section 4, Simple Interest Basics. We are entering the territory of actual wealth building now. If you want to genuinely understand finance, and if you want to crush the middle section of your math paper, you have to memorize and master this exact formula. SI stands for simple interest. It equals P, the principal, which is your starting pile of money, multiplied by T, the time in years, multiplied by R, the annual interest rate. You take all of that, multiply it together, and divide it by 100. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, back to the formula. Remember, this is strictly a linear formula. You only ever earn interest on the original pile of money you put in at the very start. Let's execute our success blueprint and plug some numbers in to see it in action. You walk into a bank and deposit a principal of $250. You leave it alone for a time of 6 years at a steady, simple rate of 8%. If we follow the formula perfectly in step 2, we multiply 250 by 6 by 8. That gives us 12,000. We then divide that entire top line by 100, and our simple interest earned is exactly $120. It's clean, it's totally predictable, and quite frankly, it's easy to calculate. Just remember to read the question carefully. Did the examiner ask for the interest earned or the total amount to the bank? If it's total, you've got to add that $120 back to your $250. But as we're about to see, simple interest is absolutely not the most powerful force in finance or on your exam paper. Welcome to Section 5, the compound interest formula. This is where the stakes are the highest and where the grade boundaries are decided. Let's compare these two beasts directly. We just conquered simple interest. It's linear, it's flat. It only ever calculates interest on your original principal. But compound interest, that is pure explosive exponential growth. With compound interest, the bank pays you interest, and then they permanently add that interest to your principal. The next year, you earn interest on your original money, plus the interest you already earned. It's interest stacked on top of interest. It compounds. Let's do a quick visual scan here. If you see compound in the exam question, you need to instantly switch your brain from a straight line to a massive upward curve. Let's see how this plays out in a high-stakes scenario. Here we have a massive scenario. A builder in Spain who borrows €500,000 at a 10% compound interest rate. Let's do the math manually, year by year, just to see the mechanics. In year 1, we multiply €500,000 by 1.10, so he now owes €550,000. Now here is the brutal compound trick. In year 2, we do not calculate based on the original $500,000, we take his new total, 550,000 euros, and multiply that by 1.10. Now he owes 605,000 euros. By year 3, we multiply 605,000 by 1.10 again, bringing his total towering debt to a staggering 665,500 euros. Now, calculating it this way works, but if the exam asks for 15 years, you're going to run out of time. Did you notice the mathematical cheat code we were using on that last slide? This is incredibly important. It's basically the secret weapon for the 0580 syllabus. To increase a number by 10%, you absolutely do not need to find 10% and then manually add it back on. You just use the multiplier concept. Multiplying your principal by 1.10 gives you the final total amount instantly. The number 1 represents the full 100% of the money you started with, and the 0.10 represents the 10% growth you're adding. Grasping this single, elegant concept is the bridge to unlocking advanced exponential formulas and saving yourself massive amounts of time on the clock. And why do we need to understand this exponential power so deeply? Because I want you to look at this number on the screen, 165,500 euros. Going back to our unfortunate Spanish builder, his original loan was $500,000. His final bill after 3 years was 665,500. That means this number right here, 165,500 euros, is purely the extra interest he owes after just 36 months. That is the sheer compounding weight of debt working against him. When you calculate these answers in an exam, always do a reality check. Does the size of your final number logically match the explosive power of compound growth? If it's too small, you probably calculated simple interest by mistake. Now, doing this year by year is fine for a tiny 3-year loan, but what if the exam throws a 30-year mortgage at you? That's where this elegant, all-in-one compound interest formula saves your life. The total interest I equals the principal P multiplied by our magic multiplier, which is 1 plus the rate over 100, all raised to the power of n, the number of years. Then, you subtract the original principal at the very end to isolate just the pure interest. By raising our multiplier to the power of n, we mathematically stack those compounding years on top of each other in a fraction of a second. This is your ultimate time management matrix. Memorize it, write it down immediately when you see the word compound, and secure those top marks. So let's put our entire system to the test with a highly practical and frankly alarming question straight from the deep end of the text. If you have a viciously high compounding interest rate of 27% a year, how long will it take for your debt to double entirely? Think about that multiplier concept we just mastered. A 27% increase gives us a multiplier of 1.27. If you're an extended tier student, this is exactly the kind of puzzle they will throw at you to test your logic. Let's execute our strategy and see it in action. Look at how aggressively fast this moves when we apply the powers. In year 1, multiplying your principal by 1.27 means your debt is sitting at 127%. In year 2, we simply square that multiplier, 1.27 to the power of 2. Suddenly, your debt is at 1.61 times its original size, meaning it's at 161%. In year 3, we cube it, 1.27 to the power of 3. And there it is, 2.05. The command word asked when it would double, meaning when it crosses 2.00. In just 3 short years, a 27% interest rate pushes your debt completely over the 200% mark. It has officially doubled. That is how you use trial and improvement with multipliers to absolutely crush a complex Cambridge question. And that brilliantly illustrates the silent, mathematical reality of the money life cycle and exactly how to beat the examiner at their own game. Which brings us to our final thought for this session. If a 27% interest rate can mathematically double a debt in just 3 years, how is exponential growth secretly working for or against your money right now? Take the formulas we learned today, look at your own savings, your own loans, and do the math. You might be completely surprised by what you find. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.